Right, so Agritechnica 2025, het sal hom nou nie reg wees nie. Dat ons nie al die drones cover nie. So ons is hier by EA Vision. Ek praat met James, die een wat PACSys inbring. Hy J150. Hy gaan ons 'n bietjie meer vertel. Presies, wat kry jy in daai drone? Hoekom is hy dalk net die een vir jou? Hoe het hulle aan hom die ontwikkeling gewerk? Kom ons klim 'n bietjie onder die rok van hierdie company in. James, how are you doing?
Yeah, it's great. How are you doing?
No, good, thanks. Yeah. Okay, so before we get into the technical stuff and the nitty-gritties of the J150, tell me a little bit more. EA Vision,
sure.
Who are you guys, and the company as a whole?
Sure. Okay. Yeah. Thank you for the questions. EA Vision, we are from China. We are on the tier 1 of the branding for the agriculture drones. We actually already launched for our company for around 10 years.
Yeah.
Since the very beginning. Yeah. The funny story is our owner of EA Vision was the owner of Chinese high-speed train.
Yeah.
So he brought a lot of high technologies and to EA Vision. So we have the value is to give the benefit to the farmers and the agriculture, and that is where we started from the very beginning till now. So EA Vision, this is the J150, the latest model that we launched for overseas market. We have the radar and lidar, and the best advantages that we are having in this industry comparing with all the others is firstly the obstacle avoidance.
Yeah.
Secondly, the nozzle and the droplets. Regarding the obstacle avoidance, we can do 40 meters in advance with 7.8 meters per second of the flight speed.
Yes.
Then we can avoidance the obstacle with precisely to 1 centimeter.
Jeez.
Yeah, at the same time, I'm not mentioning about others, but it's critical advantages. And talking about
that's all to do with this lidar thing that you've got here in the front, hey? And do you use the camera as well for that? Is it the combination of the two?
Yes, for sure. It's a combined system for the obstacle avoidance. But the cameras is mainly for using once the drone is working, but not for the obstacle avoidance. Because with the radar and the lidar, it is completely enough. Yeah. So I shall continue. We also have very good performance, especially for the hilly area for all charts.
Yes.
For example, we can do the vertical height obstacle avoidance with 15 meters.
Yeah.
Which is, for example, some of the other brands they are doing can be maximally around 3 meters height, which is quite easy to be in the real working scenario to be higher than this height because we also need to calculate the angle of the hierdie and then the all-chart height. But for us, 15 meters, which means we can work perfectly for most of the working scenario. It doesn't matter how complex this environment it is. Yeah, that's why we think we are the only one brand who can do the real operation without any manually by the pilot operations. Yeah, but from the very beginning to the end, completely automatically done by the drone itself. Yeah.
So fully autonomous.
Yes, exactly.
Okay, and then when we look at the construction a little bit, tell me, so you've also got a 4-motor configuration, not 8 blades, if I can put it like that.
Yeah.
Why was this the direction that you went?
Sure. First of all, we do believe 8 motors has its advantages. For example, in case one of the motor may broke or have accident on the air, it may give the extra capacity for the motor for the drone to fly it back safely. This is what I see the advantages.
Yeah.
But unfortunately, agriculture drone is not just as a drone, but really working as a tool for agriculture.
Yeah.
So we need to make sure the droplets should be on average with perfect coverage of the crop. That is what we aim for. So with 4 motors, we can make sure the wind size or the environment by the wind for the chemicals spraying can be perfectly.
So you get a more even spread, if I interpret you correctly, with 4 blades. You get a more even spread than you get with 8 blades. You maybe get more turbulence.
Exactly. Yes.
You see. Okay, and talking of the droppers, because you've got a unique setup here where you've got these two two nozzles on the sides, and I mean the one component that I really like is this, where it can bend. And so did you also? Because I mean I've spoken to a few guys and they all said it's not if a drone goes to ground, it's just a question of when. Okay, so somewhere the drone will be crashed, and if it goes to ground, then at least these things aren't breaking off; they're just folding away.
Yes, exactly. You're quite professional in this sector. Yeah, and talking about the nozzles, not just because of this kind of the structure designing to make sure the safety or to protect itself, but also the nozzle is completely designed and produced by ourselves, by EA Vision. We own all the copyright for it.
Yeah.
And also, this is the Mr. Nozzle. We, from the very beginning, we produced and designed by ourselves, and we improved till now. Take J150 as an example. The droplet size can be on average, and also the size range can be from 10 micrometer to 300 micrometers.
Yeah.
So on average, at the same time for the other models from the other brands, they can do normally started from 60. So the biggest difference between 10 to 60 is especially for some critical diseases, mainly for orchards. I will give an example. For example, like the red spider disease on orange. So this kind of disease can only be cured by the droplet size below 40 micrometers. In this whole industry, we are the only one who can do so.
That can actually put down that 10 micrometers droplet size.
Yes, we can do minimum to 10.
Okay, so when I see this is carbon fiber, and so also on the construction, I'm guessing because it needs to be strong and light. But what was the things that you considered in the construction of the drone itself?
Okay, so talking about the design of the construction, why in this way? First of all, from the front side, for sure, the radar and lidar combination system should be on front because the drone is fly from the back to the front. And then why we put the nozzles backside? Because previously we designed the nozzles just each nozzle to each motor, but that nozzle, the chemicals spring may more or less affect of the radar and lidar system. So that's why we shifted back, and I think this is also the same tendency for this whole industry. Then we try to make the general weight of all the construction of the drone as lighter as possible, because we really want to make the full performance by the drone, by the capacity for the tank, for the spring system, as bigger as better. And then we have the batteries put in backside, so that can be well protected.
And I also see that you've got the poles are far away from each other, so that there's no risk of shorting. Is that correct?
Yes, for example, exactly. Yes.
That's actually very, very cool. And so you will just slot in the battery here, and I'm guessing then your weight distribution is also good.
Yes, for sure.
Okay, so when we're looking at the, just explain to me quickly the spreading system that you've got on here.
Sure, okay. The reason why we design in this way, first of all, we have to make sure the tank will be big enough. For example, this we mentioned with 100 liters can carry 80 kilograms of the for the spreading system with fertilizers or the seeds. From our point of view, it is not tall enough because the tallest one is the radar system, and to find the proper balance of the center of the gravity. So this is the design in this way. But then we are talking about this shape.
Yes.
This angle. Why this angle is so big? Because we need to make sure whatever the material it is for spreading, it will not be stuck here. Right. So with enough angle, we can make sure it will be fully used perfectly. So generally speaking, that's the main reason why this design structure is like this way.
With you, and then when we look at this is the spray unit, so that's the spreading unit. And you've got impeller pumps on this. Am I correct?
Yes, it's the pump. Yes.
Okay. When I look at the pumps, how many liters per minute can they deliver?
We can spray 40 liters per minute.
So 40 liters per minute that these kind of things can deliver.
Exactly.
That's awesome.
Yep.
So on the spreading system itself, I'm guessing you went that route because it gives you an even spread, am I correct?
Yes, exactly. For both the spreading system and the spraying system, we've done 1,000 times of the test or more than 10,000 of the testing to find the best balance of all the structures designing. For more details, it's not quite easy to share, but the result is, especially for the spraying, because the spreading is more or less easier designing comparing with spraying. So now the system is in a perfectly range that with the pump and the tank of the spring with the perfectly designed by ourselves of the nozzles, the droplet size are uneven, and I'm sure we are on top one now, especially for the droplet size even average.
Last thing, so in China, I mean, there's a few big agri-drone companies there. How many of these drones have you got flying in China, spraying there?
Oh, it's around 1,000 or more than 10,000 of the drones flying there.
So it's a few thousand of these drones already,
yes.
already there and spraying and going on.
Yes.
So it's not like there's only 3 drones running there.
For sure, for sure.
Awesome, James. Thank you very much.
Thank you.
Okay, EA Vision nou aan jou verskaf deur PACSys. Okay, so as jy belangstel, dak drone daai, linkie bo of onder. Okay, met hulle in kontak kom. Dan kry jy enetjie wat so hier, ek sê, gaan hom lekker baie vinnig volmaak af van die bokant af, nê. Dis nie van Farmspace af, tot volgende keer. Groete.